Hello everyone, my name is Hong Seung Ro, working in Korean Transport Institute. First of all, I'd like to appreciate the Aragonese government and the Platform Logistic Organization for supporting today's sixth World Forum Cities and Logistic Platform. And I would like to express my special thanks to Mr. Hector Vargas for giving me the opportunity to present today. At this time, when carbon neutrality is emphasized, many policies and technologies are being developed in Korea as well. Today, among other things, I am delighted to have the opportunity to introduce to you a new green logistic technology platform which I am currently developing and called AutoCon. Uh, this research was supported by the Korean government budget. So at this place, I'd like to express my special thanks to Korean government to supporting the grant of this research as well. Before starting my presentation, I would like to introduce about my um, the research institute first. The Korean Transport Institute, called KOTI, is an official research agency for the government of the Republic of Korea. The mission of KOTI is provided recommendation and alternatives for the nation's transport policy and creating the optimal transport system through the specialized research and technological innovations, while positioning itself as one of the world's leading transport research institutes. It's kind of the non-profit research institute, different from the another consulting company. Not only for the Korean government, but also we supporting the many international institute like a UN or World Bank or some OECD, something like that. Among this institute, I'm working for logistics research. So this kind of today, I'd like to introduce about the logistics technology that I developing in this institute now. Today's presentation is consist of the four parts. The first part is introduction, and second part is the relevant technology trends, and third part is the outline of R&D project, and finally I will conclude with the conclusion. Uh, Chapter 1 is introduction. I will introduce about the background, the aims of the R&D. Development of the automated intermodal freight transport system is required to maximize transport and energy efficiency by minimizing cost and greenhouse gas emissions. Limits of the road freight transport is a kind of the critical point in Korea because Korea is a very small country comparatively another Europe countries or another world countries. So there is a limits, strong limits of the alternative transport modes. For railways, problems occur due to the expressive new investment cost and extra facilities for unloading and loading procedure. So addition of the railway unloading stages, track capacity limit, and passenger priority policy is a kind of a serious problem in Korea. Except the railways, we can consider of the coastal shipping as well, but timing and the stability occur due to the unpredictable weather conditions. So 97% of the national transportation is depends on the road transport, like a truck or trailers. This kind of problem is kind of the background of this kind of new technology development. Chapter 2, I will introduce about uh, relevant technology trends. As you see on the picture, there are so many transport technology is using in the world, and this kind of technology is developed time to time. Individual trucks and vehicles, containers, uh, technology is developed to another using the another energy. It's kind of a hybrid truck or truck train or some platooning system is applied to develop the efficiency of transport now. And so many electric trucks is applied to the field. And in Korea, the hydrogen fuel truck is also developed. In the future, the green fuel or new energy will be used for transportation, freight transportation. And auto platooning and another operation system also, technology also developed. So in the future, unmanned automation will be general. And to increase the efficiency of the stacking, we are developing the double stack train or urban railway utilization logistic technologies also developing. And in the future, underground will be used for the freight transport. And modern logistics facility is not only consumption of energy, but also this kind of facility will be used for generating new energy in the future, including the solar energy or wind energy, something like that. There are so many efforts, not only in Korea but also overseas. Automatic freight transport system, especially in USA, America, and some Europe, including the Sweden and Belgium and Germany and Netherlands. There are so many efforts is conducted now, not only the underground but also over the bridge. So many transportation new technologies developing. This table is a summary of this kind of technology development. Uh, Among them, part of it is on the developing procedure, but part of it is stopped to developing. So you can see the country and the transport method and trap technology and control system and loading technology, something like that. Uh, if I summarize that this technology depends on the countries, I will introduce about the Korea first. Since 2010, R&D technology planning research has been started in Korea. So since 2010, technology advancement has been formed, such as ArtCon, Korean ATS, and Actube, some systems, and so on. A representative example of research is ArtCon system, developed by the Coty, and I will introduce today. If you have interest in it, then you can refer to this kind of the case studies shown in the slide. And in another country, since late 1900s and early 2000, 2000, the US and Europe began to focus on the eco-friendly transport system technologies developed into automated cargo transport system between logistic hubs, real-time upload prevention system technology, tube-type underground freight transportation system technology is developing now. Still in the pilot operation level due to the high initial investment cost. Invest, Intensive competition among FSS, the ACT, ECCO, Skytech, UCM, and these kind of the technology is developing now. But unfortunately, until this time, one of there is not general this kind of the new technology in the real world, except the model law. In the right hand side, you can see the model law is invented by the France. The law is a company name, and the system name is a model law. A system is developed by the Loa Group in France to transfer trailers to freight cars by rotating the freight cars. And cargo handling begins after obtaining an access permit and passing a storage area. 5 or 6 professional operators are stationed in the 350-meter terminal of 350-meter delivers and 30 cars in the single arrangement. Commercial operating connecting the 175-kilometer section between Alton in France and Ovarsano in Italy and Luxembourg is operating now. But because of the high investment cost, another extension or another new investment is not occurred until this time. If I summarize this kind of trends of automated freight transport system technology development, you can see this kind of 5 perspectives. From the transportation perspectives, most of the system is automated system, and the dedicated routes is using for transport, and intermodal system is emphasized. From the automation perspective, manpower reduction, cost saving, and safety encouraging is kind of the impatient. If I say about the spatial perspective, elevated infrastructure is using for many countries from the ground. And another energy perspective, electric power is usual. Electric motors is very efficient to propel this kind of vehicle. So most of the new technology using the electric power is kind of characteristics. And in case of the cargo form, most of the cargo is shaped by the containers. Container trailer or container boxes is kind of the unit of transport. Let's move to the chapter 3. I will introduce about outline of my R&D project in Korea. Before starting the introduction of my technology, I will show a short the video to introduce my technology. Okay. Okay, have you enjoyed the video? It was very short video, but it was very sufficient to understanding of my system. The project name of this technology development is Automated Intermodal Freight Transport System, and this project started from 2017 and is continued until this year, and this project will be finished the end of this year. This project is hosted by the COTI, and the budget is 13.6 billion US dollars. Among them, the 10 million US dollar is supported by government, and 2.8 or 2.9 million is supported by private sectors. So it's not a small project, and we are continuing to develop this technology until by this year, the end of this year. This project team is consists of three parts. First part is infrastructures, and second part is vehicle and propulsion, and third part is system operations. Uh, as you see, the total 9 companies is supporting this project, and almost 100 people are working develop this technology now. The vision of the this R&D is a global leader of automated intermodal transport system technology, and the goal of this project is realize a real-world demonstration and the model implementation. So there is 4 goals: feasibility for leading technology development and cost reduction by 10% comparing to the existing railway system, and the detailed strategy for technology development, and the reorganization of a legal system for domestic realizations. There are several directions from the social SOC investments perspective, from the largest scale investment and maintenance. It will change to reduced investment and the maintenance cost. And in innovation terms, the man or mechanized system to unmanned or automated system. Uh, Climate change's perspective, fossil fuel use to low carbon, high efficiency. Transport safe perspective, individual non-standard transport to continuous unit load transport. Finally, efficiency perspective, efficiency of the individual transportation to efficiency between mode of transport. There are 4 strategies is developed for developing this kind of the technologies, and this core part is developed divided into 3 parts. The final goal is of securing the technology for real-world demonstration model implementation, and as I explained, we established 4 main goals, and there are so many specific technology development goals, and this kind of development, the technology development is consists of 3 key areas. First one is infrastructure. Second one is vehicle, including the propulsion system and operation systems. Uh, right hand side, you can see the detailed technologies about this technology. Transportation infrastructure system is continued for 4 years, almost 5 years, and we finished constructing the pilot test. It's kind of test bed in Korea. Now, as you see, the construction we built already 400-meter long railways dedicated for this autocon system. And second part, transport and vehicle and the propulsion system is almost finished, and we finished to make some real size train. And third part is operation system. We also finished to develop the operation system. Now, uh, as you see, uh, we finished to make the real size train, and this is operating now. You can see the short video about this one. Yeah, as you see, this train is moving on the dedicated the railway now, and we are continue the testing between the 400-meter long test bed in Gwangyang Port. It is located in the southern part of Korea. It's a famous container port in Korea now. So this kind of the testing will continue by the end of this year, and this test bed will operating not only this year but also next year or the year after for several years. So if you're interested in to this system, then please welcome to Korea and find the test bed in Korea now. As you see in the short video, the system is operating following this kind of the processes. First one is container vehicle entry to the terminal and loading on the train without any cargo handling facility like crane or forklift or a top handle or something like that. There is no cargo handling equipment or facilities not necessary. And second part is a container trailer loading on the train. It's like a parking of the in parking lot. So the truck drivers or trailer drivers drive by themselves on the train along the lane very easily and remove the tractor. So the container on the trailers remain on the train, and there is a very short lasting process. After that, the trains depart terminals and move to the end of the terminal. So during the after the transport sections, they will arrive in the another terminal, then transition section entry, and they move the wagons along the rails, and they rotate and they enter the terminal. And after the arrival, the trailers rejoined to the trailers and tractors, and after that the trailer unloading process is started. After that, the operation is finished. This is kind of very simple process, but it's very strong procedure because we don't need any cargo handling facilities or equipments, so we can save cargo handling cost. Metal in fact, in short distance transport, the cargo handling cost and the transport cost is quite usually mutually the same. So if we save the cargo handling cost, means we can save half of the logistic cost in the conclusion. So I will summarize the advantages of technology. This technology using the roll-on, roll-off container handling system to reduce loading and unloading cost. The loading unloading process of train is not necessary, and simultaneously loading unloading work is available. It means zero loading and discharging cost. As I mentioned, in the case of a short distance shuttle transport, loading or unloading costs are equal to transport cost, and actual transportation costs are reduced by half of it. And second strength is construction cost saving, and individual operation is possible by excluding the locomotives. As you see in the video, there is no locomotives. By excluding the locomotives with a weight of 150 tons to 200 tons, it's very heavy. It is only necessary to supporting the weight of the vehicle of about 60 tons per vehicle, making it possible to reducing weight of a railway roadbed structure and significantly reduce the construction cost. Uh, After the calculation of ourselves, the infrastructure construction costs account for 70 to 80% of the total project cost. So if we can save the cost of the construction, the weight, then we can save a large part of the construction cost. And finally, elimination of working tracks and shunting works and shortening the effective lengths. No need to construction the separate work line for loading unloading and to operate the shunting locomotives. Uh, Maybe you can understand in Korea most of the railways is railway train. Train is operating by electricity. So every railway track uh, have a pantograph, the electricity power supply cable above the rail. So uh, on the track, on the train track, we cannot handle the containers because of the power line on the track. So we have to make another separate walk lane from the depart from the operating tracks. So uh, usually, if we operating the container train in the railways, then we make this kind of the separate works. And without the power supply, the electric locomotive cannot operate it. So we have to switch the shunting locomotive operating by the diesel. So it's kind of very complicated procedure. So shortening the effective length and also required to stopping the train by folding it when the railroad car is stopped. So if we use this kind of system, then we can make very short and small railway container yard. So it is very efficient compared to the existing railways. This is kind of the conclusion. Uh, we develop technology utilize reusable energy, especially electricity. Actually, electricity power is not the zero emission. The carbon utilization is not realized. Actually, on the procedure to generate powers or electric powers, we have to make some carbon, but comparatively it's kind of the low carbon reusable energy, so we can considering about this energy. And eliminating unloading process, we can save the logistic cost. And we don't need any cargo handling equipment except truck and trailers. And we're considering about the unit cargo, especially container boxes first. And we can apply this technology not only the containers but also bulk cargo or general cargo, including the cars. Uh, Maybe you can imagine the Tesla, the company, the American company, transport the private cars using the Hyperloop on the ground. But this kind of technology, this technology also applied to the transport private car as well. And first of all, we targeted the application region is between two connected hubs, between logistics hubs, such as seaport or inland container depot or hinterland, something like that. And for the economics of the investment, the larger cargo volume is better rather than small cargo volume. Technology is already mentioned, so I will uh, stop the explanation about technologies. This is conclusion. The result of this study that I reviewed the Korean and international intermodal automated transport system, and I will summarize the trends and direction of the automated transport system under development. And eco-friendly transport technology has been developed in not only Korea but also in Europe and the US since 2000. Most of the countries has the pilot project level still, but continue due to the high initial investment cost of developed technologies. But Korea is almost the last stage to finish to develop the technologies, and I hope this kind of commercialize starting from next year. Of course, there's so many limitations of this study. Identify the cause of the failure in the commercialization, and I have to prepare the practical strategy for commercializations. And improvement of the legal system is necessary because it's kind of the new technology to apply real world. So this kind of the limitations have to overcome in the future. Okay, this is the end of my presentation of today. Uh, it was very short presentation, but uh, I strongly believe there are so many participants or audience have interesting in this kind of new technology. So if you have interesting in not only in academia but also in business perspectives, if you have interesting in that, please contact me anytime. Don't hesitate. Okay, thank you very much for attention until this time. I hope to see you not only in virtual but also in directly face to face in the future. Be safe from the COVID then. Thank you very much.